Hello everyone, welcome back to my channel Ankura Education. Our today's topic is band theory. Band theory describes the solids in a better way. According to the band theory, solids have two kinds of bands. One is the conduction band and the other one is a valence band, CB and VB, for our convenience. Now, let us explain the conduction band and valence band with an example. Consider silicon whose electronic configuration is given by 1s2, 2s2, 2p6, 3s2, 3p2. The atomic number of silicon is 14, so it can contain only 14 electrons. We know that the first and the second orbits are completely filled, whereas the third orbit is incompletely filled, and in the third shell we also have a subshell D. So let us take this as 3d0. So the 3d, that is the third subshell D, is not filled. Let us consider this as valence shell. We know that the lighter things will be at the top and the heavier one will be at the bottom. Similarly, in our case, the subshell with electrons will be at the bottom, that is S and P, and the one with no electrons will be at the top. In S subshell we have 2 electrons, in P subshell we have 2, and in D we don't have any electrons. So there exists a gap between P and D subshell. This gap is known as the forbidden gap and is denoted by Eg. This is a very important concept in understanding the solids. Based upon this forbidden gap, the solids are divided into 3 types: insulators, conductors and the semiconductors. For any kind of solid, there exist 2 bands that we already discussed, that is the conduction band and the valence band. The conduction band has no electrons, that means it is empty, and the valence band contains electrons which are free to move. This is the filled with valence electron. The electrons in the valence band are not supposed to move to the conduction band, as there is a long gap between the conduction band and the valence band, that is Eg is approximately equal to 6 electron volts. So the electrons in the valence band it is very impossible for the electrons in the valence band to move to the conduction band, as there is a long distance between the conduction band and the valence band. The energy gap is given by 6 electron volts. There is no movement of electrons from valence band to the conduction band. There is no conduction taking place. So the examples for insulator are diamond and quartz. Diamond is a very good example for insulator. Even though if we apply an external field, then also the electrons will not move from the valence band to the conduction band. So we can say that the insulator is a solid in which the electrons cannot move from valence band to the conduction band even though the external field is applied. Now consider the another case in which the conduction band of a solid overlaps with the valence band. That means the energy gap between the 2 bands is 0. So the valence electrons in the valence band Eg is 0 electron volts. So the valence electrons in the valence band can move very easily to the conduction band without any application of field. The movement of electron from valence band to the conduction band cannot create a empty hole here, because as the electron moves to the conduction band, the other one replaces it as soon it moves to the conduction band. So there is no formation of hole in case of a metal or conductor. So the metal is a solid in which the movement of electron from valence band to the conduction band is very easy. Example for conductors are copper and silver. Copper is a very good conductor. Consider the other possibility in which the gap between the conduction band and the valence band is less, that is CB, VB and the gap between these two is less, say approximately 1 electron volt, then the electrons in the valence band cannot move to the conduction band by themselves, but as the temperature is increased, the gap between them can be decreased. So the electrons from valence band can be moved to the conduction band. As the electron moves, it creates a hole in the valence band, because the electrons here are strongly bonded to their parent atom, whereas in case of metal, the electrons are very free to move. So this kind of solid is known as the semiconductor. Examples of semiconductor are germanium and silicon. They are very good semiconductors. Energy gap of semiconductor is not a fixed value. It depends upon T. As the T value, T means temperature. As the temperature is increased, the energy gap between the conduction band and the valence band decreases. For germanium, at 0 degree Kelvin, the standard value for the energy gap is given by 0.785 electron volts, whereas for silicon at 0 degree Kelvin, the energy gap is given by 1.21 electron volts. As the temperature is increased, their values reduced by an amount of Eg is equal to 0.785 minus 2.23 into 10 to the power of minus 4 T electron volts per degree Kelvin for germanium, and for silicon its Eg value reduces by 1.21 minus 3.6 into 10 to the power of minus 4 T electron volts per degree Kelvin. Hence, we can say that the energy gap is a function of T. The movement of electrons in the solid can cause the current to flow. Hence, we can say that the semiconductors are the solids in which the movement of electrons from valence band to the conduction band depends upon the temperature and the external field. There is a less amount of conduction taking place in case of semiconductor. Let us now discuss some of the parameters related to conductors, insulators and semiconductors. The value of resistivity is less than 10 to the power of minus 3 ohm centimeter for conductors and greater than or equal to 10 to the power of 9 for insulators, and its value lies between 10 to the power of 9 minus 3 and 9 for semiconductors. Similarly, the electronic configuration N value is 10 to the power of 28 electrons per meter cube for conductors and 10 to the power of 7 electrons per meter cube for insulators, and its value lies between 10 to the power of 7 and 10 to the power of 28 for semiconductors. 10 to the power of 7 and 28 for semiconductors. So, I hope you understood the difference between the insulators, conductors and semiconductors. So, thank you for watching my video. If you like my video, please do like, share and subscribe. Next, in our next video, I am going to discuss about the semiconductors, germanium and silicon in detail. Please don't forget to subscribe my channel. Thank you.